This conference will now be recorded.
So what is a heap is in the memory. Okay, when I said memory in performance testing, as you know, we are referring to RAM. Okay,
RAM.
in the RAM, a part of it will be heap. Okay, the whole RAM can be divided into multiple parts. Okay, like one part where the program will be loaded and executed. Program ante it's a set of instructions. So that set of instructions will be loaded into that part of the memory, and one by one will be executed. There will be another part of your memory wherein like Java classes and all that will be like some libraries, right? So some Java
Mhm.
libraries and all that will be there. That will be loaded, which will help this. Okay, and certain part where the data required for the programming will be loaded. Like this, different parts of our memory will be used for different purposes. Like that, one part of our RAM or one part of our memory is the heap memory. Okay, is the heap memory. So what exactly it is when a program is running, like if it's a C program, you have there will be some variables. Okay, there will be some variables if a program is running. Okay, so let's assume it's a C program, so then there will be a variable whenever you are executing that piece of code which will declare a variable. A piece of memory, a small piece of memory is allocated to that, so that that particular value will be stored into it. So for example, in the program you said int I is equal to 1. Okay, so what
Mhm.
happens as soon as this instruction is executed? Okay, this instruction is executed, a small piece of memory in your heap, okay, a small piece of memory is allocated to variable I, and 1 will be stored over here. Okay, so the ideal thing is, as long as you are using I, there is no problem keeping this piece of memory active. But once you are done using I, okay, so maybe that program is ended, or in that program only the I is not required, or whatever it is, when you are not using this I anymore, you have to deallocate this memory so that the same piece of memory can be allocated to some other object or some other variable. Are we clear with that?
Yeah, clear.
Okay, why? Because you have some set of memory. You don't have infinite memory, you have only finite memory. So once you have used it, once you have allocated it, and once you're done with that, you have to unallocate it so that that memory will be freed up, and then it can be allocated to the new way. Okay, so if this is what is the C program, but if it's a Java, okay, if it's a Java programming language, there is a concept called objects more than the variables. Okay, there's a concept called object. Whenever you instantiate a method, there will be an object that is created, and the Java program will be using that object. Object is more like a variable, but is on a bigger scale, right? So,
Yes.
and once you're done with that, automatically that piece of that object needs to be cleaned. Okay, or that object should be unreferenced, or that object should be taken away. If it's a C program, you have to add a piece of code in a program itself saying that free of memory or free I or something like that. You have to add a piece of code to that. But if it's a Java program, which is an object-oriented programming, automatically that piece of memory will be cleaned up. You don't need, as a programmer, you don't need to add an extra piece of code for cleaning up that memory. Okay, there is already a program which is inbuilt, which is called a garbage collector, which is the program which is inbuilt, which comes with the Java programming language. So this program will take care of that, and it will be cleaning up. Okay, it will be cleaning up that piece of memory. Okay, so this
Okay.
heap memory that we are talking about, which I said is a portion of the overall RAM memory, a heap memory is a part of it. In this heap memory, these objects will be created and these objects will be killed as well or taken away. Okay, the GC will come over and take away all the unwanted objects. All the unwanted objects. So what happens as the program is running, it's not one object, but there are hundreds of objects that will be created. Okay, so if you don't leave it, if you completely leave it unattended, within no time, the whole heap will be filled, and when there is a new object that needs to be created, there will be no memory for that. So that is the reason why this GC has to come and take away the objects continuously. Okay, GC is what? Garbage collector, which is a program which will clean up these objects. The objects which are old, which is not required anymore, needs to be cleaned up. So the GC program will come and take care of it. Okay, are we clear with so far?
Yeah.
Okay, so there will be certain times what happens is the object, even though it's not required and your GC is not collecting it or GC is not cleaning up, then over a period of time those kind of objects will be increased, and even though the GC is trying to clean it up, they will not be cleaned up for multiple reasons. Okay, there could be dead loss, the program is not properly designed, or objects, there could be 100 reasons why that is happening. But if that continues to happen, what happens is over a period of time the objects which are not used as well, they will be in that heap memory, and over a period of time they keep increasing, and this condition wherein the the objects continue to increase and the available memory decreases, that condition is what we call it as a memory leak. Memory leak means the objects continue to increase, they have to be taken away, but they are not being taken away for whatever the reason. So they are continuously increased, which means that the heap used memory will be more and the available memory will be less, and over a period of time they continue to increase, available memory will decrease, and this memory will increase. At a point of time there will not be any more memory for the new creating objects or new coming objects, and this situation is what we call it as a memory leak. Are we clear, Aman?
Yeah, clear.
Okay, now we will look into this particular portion which I am calling it as a heap memory. Okay, let's have a closer look at this portion which we are calling it as a heap memory. Is what? A part of overall memory. Whenever I say memory, what am I referring to? I'm referring to a RAM memory, not a hard disk memory or a cache memory. Okay, so as I've told you, there are multiple portions of it, and one of them is the heap memory. Okay, so let's look into it. This heap memory is overall divided something like this. Okay, so it will be divided into old or tenured generation, permanent generation, and in this young generation will be further divided into three parts, which is Eden, Survivor 1 and Survivor 2. Okay, I will repeat it again. Overall, this heap memory that I am talking about is actually divided into three portions or three categories or three generations. They can leave it completely as it is, but there is a good reason why we need it to categorize it or divide them into multiple generations. The whole memory, they cannot keep it as one single bunch, because when we categorize it, we have multiple advantages which we will discuss in our next slides. Okay, first in your interview you have to talk about these generations. What are the three generations? The new generation, old or tenured generation, or permanent generation. The name suggests it's a permanent, which means that the GC will not come and take it away. It is a permanent in some nature. Okay, so the GC will not clean up this permanent generation, because this permanent generation completely consists of something else other than the objects. Okay, so you have young, old and permanent. If you can remember this, it is good. Young, okay, new generation or young generation, old generation or permanent generation. In this new generation will be further divided into Eden, Survivor 1 and Survivor 2. Okay, it is extremely important you talk about all these generations when you're talking in the interview. New generation or young generation. Think like this: new, old, or young, old, or permanent, or new, old, or permanent. And these are generations. In this young or new generations, you have Eden, Survivor 1 and Survivor 2. Okay, so let's discuss as to why they have categorized it like this. Okay, now let's say when I'm talking about objects, let's talk about 5 objects. Okay, so as the program is running, let's say Java program. Okay, all this will be in the JVM, right? Okay, Java virtual machine, everything will be there. So JVM will be creating the thread and it will be running a program. As the program is running, let's say these 5 objects are created. What are there? A, B, C, D, E. These 5 objects are created. So once these 5 objects are created, where it will be created? It will be created in the Eden. It will not be created in Survivor 1 or Survivor 2 or tenured generation or old generation or permanent generation. generation. It is created in the young generation or new generation, that too in the Eden space. What do we call it as? Eden space. Okay. Now these objects are created. Okay, a piece of memory in the heap memory is allocated to these objects, not in any randomly like this. It is created in the Eden space of the young generation. Now let's see what happens. And one more thing you have to remember is, as we are executing the program, there are some objects which are referenced to a thread or another object, which means that this object is needed. Okay, there are some objects which are not referenced to another object or a thread, which means that this object is no more needed or it is dead. Okay, so if it is referenced to some other object or thread, which means that this object is in use. Okay, are you understanding? There is a thread running the program and you're referencing this object to that thread, which means that this object is still in need. Okay, or there's some object which is completely unreferenced, means nobody is using that, so there is no need that it needs to be there. Are you understanding?
Yeah.
Okay, so the ones which are referenced, we call it as alive. The ones which are unreferenced, let's, for our discussion purposes, we call it as dead. Ideally, we have to use this reference objects and unreferenced objects technically, but some people will use this as alive and thread as well. As the name suggests, reference means it is reference to another thread or object, which means that somebody is using it. Unreference means nobody is using it. Okay, so let's assume this C and D. As you see, this C and D are unreferenced because nobody is using it. They are unreferenced. Okay, but A, B, C, D, A, P, E is what? They are reference. Reference means a thread or a program or a process or some other object is using it. Okay, so let's consider a situation wherein these three are alive and these two are dead, in simple words. Okay, now what happens? And let's say the capacity of this Eden space is only 5. So you have reached the maximum capacity. Now a GC is what? A program will come and try to clean up this Eden space. Okay, and this GC, we call it as by a name called minor GC. What is this? Minor GC. Minor GC means a small GC. Okay, so in the GC itself, in the program itself, we have one program to clean up this space. Okay, and there is one program to clean up this old generation. The program which is there to clean up the new generation, any generation, we call it as minor GC. Now this minor GC, usually they scheduled it. Okay, people, there are two versions to it. Some people say that once the Eden space is full, automatically this will come. Some people will say that yes, if the Eden space will come, it will come and automatically clean it up, or there is a schedule time for every 10 milliseconds or every 20 milliseconds or every 1 second. It will come and clean up it. Whether it is full or not, with the scheduled time is reached, it will come and try to clean it up. Okay, usually it will be in the order of seconds only. May not be in milliseconds, but will be in the order of seconds. Okay, minor GC. Okay, so that I'll 100% confirm and will tell you later at some point of time whether it's milliseconds or seconds. Okay, I can't remember. As a performance tester, we don't get into that kind of details, but since we are going through the class, I'm telling you. But all you need to know is it will happen very, very often. Okay, don't think that it will happen once in 1 hour or half an hour. No, it will be in the order of minutes or seconds. Okay, so now when the minor GC comes, it knows that this is reference, this is reference, this is reference, these two are unreferenced, so it will take away these objects. Okay, or in other words, whatever the memory which is allocated to these objects, it will free up that memory. Okay, so are we clear so far?
Yeah, clear.
Okay, now that is the first task. Second task is to, the idea of the minor GC is what? To clean up the Eden space. So whether it is reference or unreference, it has to clean it up. So unreference, it is completely taken away, and reference once it is moving to the survival space 1. It is moving to the survival space 1. Okay, either case, now the Eden space is empty. The ones which are referenced is moved into survival 1. The ones which are unreferenced is completely taking it away. Okay, now you see A, B and E is moved to survival 1 and Eden space was empty. Okay, Eden space was empty, but the program, your program is still continuing, which means that more objects are getting created. Now let's assume FGHIJ are created as well. FGHIJ are the new objects which is created. The old objects, out of this old object, C and F is completely taken away. ABE is moved into survival space 1. Now FGHIJ are new objects, so obviously that will be created in the event space. Now again, before the next minor GC, let's assume this one is unreferenced, and not only this, it will, the minor GC will not only check in the hidden space, but it will also check in the survival space 1 and survival space 2 as well. Okay, earlier survival space 1 and 2 are empty, so the minor GC didn't do anything. But now what? The survival space 1 is also there, so in that it will check for the unreferenced objects. Here I and B are unreferenced, everything else is referenced. So what it will do, this dead objects which is B and I, it will, the minor GC will come and take away, this both I and B, and this FGH are all now they are referenced, so that are bound to be there, Now what happened to ABEGHI? Everything moved into survival space 2. Okay, like this continues to apply. Now the more program, the program will be continued to run, the objects will be continued to come to hidden space, the minor GC will continue to clean up the unreference and move the reference ones to S1 and S2. Are we clear?
Yeah, clear.
Okay, so at some point of time when the objects are old enough, these objects will move into the old generation. Okay, at some point of time when the objects are old enough, which means that these objects are continuously being used by the by your program, which means that there needs to be there. So the GC or the algorithm over here thinks that these are continuously used objects. So why the minor GC2 has to continuously monitor it? Let's move them into the old generation. So once the age of those objects are good enough, they will be moved to the old generation. As the name suggests, they are old. The objects are old. As the name suggests, these objects are young or new, which it is saying over here. Even over here, suddenly there are multiple spaces. Slowly comes from hidden to S1, then S2. Finally, it will come to the old generation or tenured generation. Then one more thing that you have to remember, Ajay, here is there will be some objects like strings and arrays. For this, they don't go through this process. They directly come to the old generation. They directly come to the old or tenured generations. Okay.
That means the
Finally,
constant variables that all will be directly coming to the tenure generations.
right. Yeah, strings and array objects. Okay. The other objects, they have to go through this space. But string and array objects, they need more space, then directly they come into the old generation. Okay. Now think about it. This process continues. At some point of time, this whole generation. Okay, let's go. So as you said, some objects will be promoted. Some objects will be promoted to the old generation, which is AGGO in this space. Okay, as I've told you, new generations, new objects will continue to create, and they continue to promote from hidden to S1 to S2, and finally the promotion happens from S2 to the old generation or tenured generation. We call this as promotion. We don't call this as promotion. We call this as moving. But here there is a specific word called promotion, moving from the old generation to the young generation to the old generation. Are we clear so far?
Yeah, clear.
At some point of time, this old generation is also a space, right? It is a limited space. It's unlimited. Also, continuously these objects are created. They are slowly moving down. At some point of time, this will be full as well. When this is full, it cannot take any more objects from the new generation. And one more thing happens is at some point of time, which were continuously referenced, they're old enough, but they becomes unreferenced as well at some point of time. Don't you think so?
Yeah, exactly. It will.
Yeah, they're living over there. I mean, they are there, but at some point of time, they might become unreferenced as well. So what happens is, whatever happens over here is a minor GC, and at a scheduled time, the major GC will happen as well. The major GC will come and take away all the unreferenced objects on this old generation. So
Okay.
whatever the GC which is happening over here is minor GC. Whatever the GC which is happening is major GC. Minor GC happens very often. Major GC doesn't happen that often. Okay,
Okay.
so
Okay.
it will be certain period of time. Okay, but again, I can at some point of time I'll come back with it as to with how many for how often this will happen and for how often this will happen. But
Okay.
one thing is, if this space is full, automatically the minor GC will be triggered, and if this space is close to full, automatically the major GC will happen. Okay. Other than this minor GC and major GC, there is something called full GC. Okay, full GC means the whole of this will be the garbage collector. The program will come and all of this will be cleaned up. Sometimes what happens is if this thing is whole of this is full. Okay, so minor GC, major GC, nothing is working out. They are doing their job, but it is full. The full GC will come and take away all the objects. Okay, all the
Okay.
objects. This happens as well. Okay, but the problem with the full GC is there is something called an event will occur. When this full GC will happen, there is an event, something like this happen. What is this? Stop the world event. Okay, the stop the world event will happen. What is the stop the world event? It is a time when all the application threads are stopped while the garbage collector operation completes. Okay, now again, you know about threads, right? In the last class,
Yeah.
we talked
Yeah.
about threads. A
Threads.
program will be executed by the threads. Okay,
Yeah.
so your application, whatever the application, let's talk about an application called Flipkart. Okay, let's talk. It's an application server and a Flipkart application is installed on that. So all the threads that will be created will be running the Flipkart application, right? Do you
Okay.
agree with me, Ajay?
Yeah, I do.
Okay. Let's say we have an application server of Flipkart. Okay, which means that the Flipkart program is running on this particular application. How it will be run? By the threads. Hundreds of threads will be there. Okay, which will be running the Flipkart program. Different threads will be running different pieces of the program. Hundreds of threads. These threads are called application threads. What are these threads called? Application threads, right? Which means that it is running that Flipkart application. These
Yeah.
threads are running the Flipkart application. And how the threads will run? By the CPU.
Right.
More is the CPU, more threads it can create. Less is the CPU, less threads it can create. Okay, so it will take some of your CPU time, or CPU utilization happens because of this application threads. Okay, now just now we have discussed that GC is also a program, right?
Yeah.
GC is
Yeah.
also a program, but it
Yeah.
is not nothing related to your Flipkart. It is nothing related to your Flipkart. It is related to your Java. Okay, but this program has to run. Then there should be threads for that as well. Do you agree?
Yeah. Exactly.
Threads should happen for this as well.
That should
But
happen. Yeah.
stop the event means stop the world event means all these application threads will not run, which means that your application is not running at all, and all the CPU will be given for running this full GC. Okay, or whatever the threads which is required for running this GC. So the CPU will be allocated only to this GC threads, which means that GC threads will be running, and the stop the world means your application is stopped. Okay, all the threads that the CPU can allocate is giving to the GC so that the GC programs will run and it will take care of the cleaning of the objects. Okay, so this is what will happen when there is a full GC. Stop the world event will come. Okay, are we clear?
Yeah. Clear.
So now, are the different algorithms for GC? Yes. Let's go ahead and discuss those algorithms.
Yeah. Sure.
Okay. The first one, probably it's not used anymore. It's called a serial GC. Okay. Or it might be used. I don't know where it will be used. Okay. But this definitely doesn't work for our at least web applications. Okay. Definitely not. Let's discuss what is this. As I've told you, these are application threads, which means that the application is running during this period. Okay. During this period. Now there's a GC which has to run. What it will do, it will stop all the application threads and only the GC thread will be run for a particular period of time. Let's say this is for 10 milliseconds or 100 milliseconds. Okay, this could happen for just 10 milliseconds, but in this 10 milliseconds your application is not running at all. Only the GC program is running. Okay, this is what is a serial GC. First application threads, then the GC threads, then application threads. So there is no parallel of application in GC. So this is why they are calling it as GC, serial GC. And here the serial GC definitely stop the world event will happen. Okay, because during this time no application threads are running. Okay, so this is definitely not suitable for our web application, wherein the application has to run continuously.
Yes.
Okay, you yourself should tell me, right? This is not
Yes.
this is not
Accurate.
right.
Why? Because means
Yeah,
if the application is getting down, obviously the performance of the application will get degraded.
don't say application is down, application is
Sorry.
up, but it happens for a
That,
very fraction of a second. It's like a pause, tuck, 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 tuck. Like a
okay.
pause. You cannot say the application is down, but it's a partial, I mean, very momentary point of time, it will halt. Okay, so you do use the word pause rather than down. Okay,
Sure. It will get
so
passed.
you see,
Okay.
DC runs on client style machine. Okay, so if it's like a client style, wherein maybe those kind of applications. Okay, so I'm not sure. Definitely, this is not recommended for the web application, wherein you need to serve thousands of users. Okay, now let's go with the parallel GC. This is what you understand now. Parallel GC, and here serial GC. One more thing you have to remember is only one thread is allocated for the garbage collector. One thread is allocated for garbage collector, and it's a stop the world event as well. Okay. Now parallel GC is recommended for some applications where is a good amount of CPU. Okay, there is a good amount of CPU. The processor is powerful enough. Then we will go with the parallel GC. The only difference between the serial GC and the parallel GC is there's a multiple threads that will be created for running the garbage collector program, which means that the program will run much more faster. Okay.
Yes. Okay.
Okay, so this is required when long pauses are acceptable. Again, they see there is a pause. The application is running, there is a pause. Application is running, then there is a pause. Let's say the application run for maybe one second, then there is a pause of maybe 10 to 20 milliseconds, or I don't know. But there is definitely a pause for a certain period of time. So if there is a certain kind of application where long pauses are acceptable, okay, and lot of work needs to be done. You see, when the GC comes, it is a powerful GC. You see, there is a parallel threads which is coming up and taking away lot of GC, which means that lot of work needs to be done. If there is something like that where lot of work needs to be done and long passes are acceptable, then you can go with parallel GC. Okay, like batch processing. Batch processing is not online processing, wherein there is no end user sitting behind the scenes actually waiting for a response, and that too in 1-2 seconds. Okay, batch processing is you kick it out in the night, and by the morning it has to process all those transactions, right? Like your salaries. Like I work for companies like Infosys and all that. Maybe they kick off these batch jobs probably night on 30 or 31st. Slowly what happens, it will take the employee name, employee ID, look at the salary, look at the bank number, and slowly deposit the money. Then like this it will continue to do it, but it happens in the background. Nobody is waiting for you, waiting for you on the browser to see when the transaction was done, right? So
Yeah.
this batch processing or printing, you see, printing the reports, performing large number of database queries, as I've told you, processing your paychecks, lot of things like this, which happens behind the scenes. No, it's not online. Then parallel GC is acceptable over there, because in this kind of environment or in this kind of places, the long process is acceptable. Okay, but you need to be powerful GC should be there. Okay, now there is another GC. We call this GC as MVC. This MVC GC, I forgot the name.
Model view controller.
Model view controller is more like a a framework to develop the application.
Yeah, yeah,
Okay,
exactly.
so model is where your program runs, view is what a person views, a
Okay,
controller is
okay.
where the program runs, something like
The
that.
replication
So
happens between the model
yeah,
and the view.
so just give me one moment. This,
Yeah, sure.
there is a name for this. There is a name for this. So let me stop the view for one moment. Okay, let me search
Sure.
it online. Okay, because this video is getting recorded, right? So
Okay.
I might share it with others as well. So I don't want to expose my desktop. Um, so it's called. Oh, oh, okay. Uh, so are you able to see my screen, Ajay?
Yeah, I'm good.
Okay, so this is called uh,
Concrete marks.
Mark Concurrent Mark Sweep (CMS). Okay, this is more like what people would use for our web applications and all the kind of applications. Okay, may not be close, but something like this is acceptable. Okay, so let's
Hmm.
see. We have application threads. Okay, along with the application threads, there will be a thread which will be happening for the GC as well. You see, now
Hmm.
both the things are happening parallelly.
Yeah.
Okay, so application threads are running as well as the GC is what is happening, but here the GC is not the cleaning up, but it is marking. So it is marking what all the things which needs to clean up. Once the marking is done, then the cleaning will happen. Okay, and that happens little quickly because it's already been marked.
Yeah.
So you see, there are application threads and there is a GC thread as well, but the GC is just marking. Okay, concurrently it is marking and it is cleaning up at the later point of time. Again, the stop the world event would happen as well. Okay, so you see the pause time is very low. You see, low pause time is needed and resources can be shared with the garbage collector. In this case, the memory and the CPU should be high. Memory and CPU should be high, and it can be concurrently shared between application threads as well as the GC threads. Okay, as you said, stop the world event occurs only for a particular one, only while marking the reference objects in the tenure generation phase, and if there is a change in the heap memory in parallel while doing the garbage collector. Only then the stop the world event occurs. But otherwise, the things are happening parallelly. But one thing you have to remember, Ajay, here is when the pause time is very less, okay, low pause time is needed, then definitely concurrent mark sweep is good. Why we are calling as concurrent mark sweep? You concurrently, as the application is running, you are marking it as well and you're sweeping it as well. That means it is cleaning up as
Hmm.
well. Okay, so this will happen, but it will happen only at certain conditions. Okay, so tenured is when the old generation needs to be marked. Okay, marking the reference objects in the old generation space is done, then only the stop the world event happens, and if there is a change in the heap memory in parallel while doing the garbage collection. While doing the garbage collection, there is a heap, this change in the heap memory, and both are is happening parallelly, then only the stop the world event happens. Otherwise, concurrently it is marking as well as sweeping the objects. Okay,
Okay.
are we clear?
Yeah, clear.
Okay, this is more like what we use for our web applications, and you should talk to your developer to see what is that he's using, which algorithm he's using. Again, in the CMS as well, there are multiple algorithms, but ask him, is this what he is using? Okay,
Okay.
CMS, mark, concurrent, mark, sweep. Okay, so since it is a low pause time, this is what it could be. Okay, but for my project it was more like this. Okay, G1 garbage first. Okay, G1 GC garbage first. Okay, here what happens is this is your heap memory, overall heap memory. Now you see how they have partitioned. they overall what they do is they create the blocks of a standard size. Okay, may it be maybe 100 KB or something like that. Okay, depending upon how big your heap is, they make a standard size of blocks. Okay, and they start marking the spots. Spaces. Okay, these are the Eden spaces. Okay, then these are the survival regions. Okay, and then there are old generations. Okay, and then there is a humongous. Humongous means a big chunk of heap required for certain things. Then these are humongous, and these are available spaces, and these are available spaces. Like this, they will do it. Okay, and what happens is when performing garbage collections, GC shows the concurrent global marking phase to determine the live and dead objects throughout the heap. Okay, like as I've told you, there will be some threads which will be running and it will be continuously watching and it will be marking where all the dead objects are there in all these particular spaces. Okay, after the mark phase is done, once the marking is done, saying that this is dead, this is alive, this is dead, this is alive, this is dead, this is alive. After the mark space is completed, G1 knows which regions contains the garbage objects. Let's say out of these spaces, let's say these are 5 Eden spaces. Let's say this space has lot of dead objects, and this space has lot of dead objects. Now this is why the method of garbage is now, so those regions are swept first. Okay, so whichever has the heavy ones, it will be swept first. Okay, so that is the reason why it is saying that garbage first. Garbage first. Okay, so let's say this Eden space, O is what? Old generation space, has lot of dead objects. So this will be clean. Okay, it will not wait for Eden to be clean. So this is what? Garbage first or G1. Okay, this is mostly used in this. I mean, these days G1 is used, and there are other algorithms as well. Okay, if we keep talking about these algorithms, it will continue to increase. But you need to understand that there are different algorithms for garbage collections. Definitely, serial and parallel is not the ones which will be used. Concurrent mark space and G1 could be the ones which will be used for our online applications. Okay, so check out what they are using right now in your project, or see in general what people use as the algorithm, and you can talk about those algorithms in your interviews. But definitely you should talk about these spaces: Eden space, survival 2 space, and old generation space. And there is this space as well, which is the permanent generation, wherein permanent generation contains data about classes and methods, and also Java libraries as well. Okay, so as it says, it is a permanent generation. So your garbage collector GC has nothing to do with this. Always your GC, minor GC or major GC, always talks about these regions, and full GC also talks about these regions. Okay,
Yeah.
are we clear? Are we clear? You got a ballpark idea as to what it is?
Yeah, I got a very good idea.
Okay, so definitely your GC will come and take. Now you will be monitoring these things. Okay, now I'll go to the Dynatrace and I will show you how this happens. Okay, there are other free tools also. Okay, but I don't have Java installed and all that. So let's go to the Dynatrace and look at how it happens. Okay, now the question is, what is that I look for? Okay, as a performance tester, what is that I look for? Okay, definitely if there is a memory leak, it is happening on your major GC. Old generation. Okay, watch out for that. Okay, how much is that? Okay, so and if it is continuously increasing over the period of time, which means that GC is not doing the right job, or there are a lot of reference objects, or there is a deadlock which is happening between the objects. So you have to talk about this memory leak. Okay, so that's the main reason that you will be concentrating and seeing how the memory will be looked at. And the second thing is, when this GC runs, okay, when this GC runs, there is a CPU that is allocated for that, right? Okay, how much is that? It should not be too much. If it is too much, then most of your CPU is going into the GC rather than the application threads, which means that definitely there is something that your developer needs to look into as to how he has designed the whole program. Okay, only 2 to 3%. I don't know the exact percentage. Again, I will come back to that. But if I remember correctly, only to 2 to 3% of your CPU should be utilized for your GC threads. Okay, or in other words, the CPU consumption for your garbage collector should not be more than 2 to 3%. Okay, continuously if you are monitoring that. Okay, if it is going over that, then definitely something that you need to talk to it. Again, those threshold numbers, I'll come back to it. Is it 2% or 5%? I can't remember exactly. I remember that it is somewhere between 2 to 3%. Okay, that's what it makes sense, right? Most of your CPU is going into the garbage collector itself. Then the main thing for that is, yeah, the application threads should run, not the garbage collection threads. Only if the application threads is running, then more and more users can use the application. But most of the GC is going into the garbage collector itself. Sorry, most of your CPU utilization is going into the garbage collector itself. Then that's not a good idea. Okay.
Okay.
And also we have to see how many times this stop the world event is happening and how often it happening also is something that we need to monitor, but I don't know how to monitor that. Okay, but that is something that we have to do, is what I have heard. Okay, now I will show you what is that I have done. Okay.
Okay.
uh, Somehow my CPU is as you see, I have now a 16 GB RAM running on it and 13.8 GB is used. That too, my Dynatrace is not started at all. So I don't know if Dynatrace will actually start or not.
And one more question, if at all the servers and everything is good,
Yeah.
they are in live, like everything, the connections and everything was good,
Hmm.
but the throughput is not happening. What could be the reason? There are no requests passing to the servers at all.
So there is hits happening, but there is no throughput at all. There is less throughput or no throughput at all.
There is no throughput at all.
There's no throughput at all. Why could be? Think about it. Let's think. I mean, now CPU utilization is also happening, which means that threads are getting created, right? Process is there. Okay.
Yes, the
How
thing
is
is,
the CPU
the requests are
utilization?
going, but all the servers are alive.
Uh,
But what is happening is there is no throughput at all.
so how is the CPU utilization?
Uh, the CPU utilizations was not that much bad. It was occupying a little bit, almost 18 to 20%. It was
Logically,
getting occupied.
the CPU utilization is there, which means that the process are getting created, right? If the
Yes,
process is getting created, then the threads are getting created as well. Okay,
yes.
which means that the
Mhm.
program is running, which
Hmm.
means that the response. Maybe did you check your sockets? I mean, how it is, whether the requests are passing through your intranet, the network utilization over there. But somehow some throughput should be there. Now, if there is no throughput,
Yeah,
definitely there
that's
should be
what.
some
That's
throughput.
a really miracle. We have checked how the either all the servers as in active or not. Something we have checked in that way. But whereas the processor also we have been checked from our client side. Everything was running fine, but we didn't
How
get
much
that
is
what
the,
is happening.
in general? How much was the CPU utilization? Did you check
18,
that?
18%, 18 to
18%.
20%. It was
That's not
fluctuating.
a problem. So I don't know. I can't really tell, but I'm just guessing that. I know I'm not an expert here, but I'm
Uh-huh.
just guessing something to do with your connections and then sockets and how they are there. Why those I'm mostly suspecting that point of view. Okay,
Uh-huh.
so
Okay.
I don't know, because if there is a CPU utilization, definitely there should be some process running, programs running. And
Yes.
how is the RAM utilization?
Memory also it was good. Everything was it was going fine, but only thing is throughput was not at all increasing. There is
It's
only
not
impact.
it's not coming at all.
There is no response at all.
There's no response at all. That's so weird.
There is no response. There is no response at all.
So network, I think you need to look into that. I
Yeah,
think that's
that's what I thought of. If the network is not there, I cannot connect to the server side. I
no,
cannot
no, no.
check the
So
server.
I'm talking about network as in app server, the database server,
Okay,
those connect. So
okay,
it
okay,
connects sockets and all that. Okay, so there's
okay.
APIs and hardware, and even in that there is a lot of technology. Ajay. Don't think that it's easy. You see Cisco, right? Those engineers pays 20 to 30 lakhs. It's a
Yeah,
huge
I
thing.
know. Huge thing,
How
yeah.
and then how they communicate, those TCP/IP communication. Lot happens over there. Okay, so
Hmm.
how and all that. I think you need to check more on those lines. Okay, so
Okay.
I'm getting, and then the database could be the silent killer as well. But whatever it is, some response should come out now. If the
Hmm.
database is bad as well, some response should come out. So individually, it's working, right? If it's one user, something is working. Application is working.
Yeah, when we used to run from the Vusion, it was getting heated. Like we have network virtualization, we have been enabled, so that we have been checked how the host is reacting and all. The requests are passing.
It is coming problem from that, or is that a control, or is your controller
Maybe,
issue? Because some
maybe
throughput
the
should.
scenario designing may be the problem, I think.
I think the controller settings you check if it's a proxy or and when you run it from the controller, did you ask the developer to see the web logs? Something is some activity is happening on the web log.
No,
I mean,
we didn't ask them. Just today only that happened. So
I
we are
think
just
it is problem.
investigating, like either is there any kind of issues from our side.
I think it is your issue. I'm guessing.
Yeah.
Maybe your sometimes what happens. I I I forget, and on the controller, I'll
Mhm.
keep the. There's a setting. What is that setting? IP spoofing on. When I keep the IP spoofing
Ah.
on, the request goes all over, and it
Oh.
happens. Yeah, and sometimes your LGs are not properly set. I think it's your performance testing or your firewalls are stopping it. Most likely, it could be firewalls. Okay,
Okay.
so run it with one user now from the controller. From the Vision, it is running. Now from
From
the
the
controller.
I asked the ALM team actually to check the firewalls and all. Either this whatever the LGs that has been provided to us, I told them to check from their side. It has been enabled or disabled, how it was working in this period
So
of
one thing,
time.
from the Vision it is working, then definitely there is no issue from the application side in the performance testing
Yes.
environment. Now from the
Yes.
controller running with one user, now it's the same story. So
Same
you're
story.
not getting response for one user, definitely it's a firewall issue. Most likely
Okay.
connectivity issue. Okay, but
Connect.
no throughput is coming definitely. And also you check if you have access to the web server, check the web server logs. There should be some activity. Okay, there
Okay.
is no
Okay.
activity on the web server logs. Definitely your request is not even going there.
Mm-hmm.
Okay,
Okay.
so
We'll
let
ask.
me start the
Yeah.
application.
We'll go with.
This application, what? Forgot this application. Forgot this application. Easy try. Okay, so we need to have some application, right? So this application I'm starting, okay, so that it will
Mm-hmm.
create some what do you say, some load. Okay, instead of
Mm-hmm.
we creating scripts on LoadRunner, running it from the controller, they have given this opportunity wherein you can control the traffic how much you want. It will automatically generate the traffic for us.
Okay.
Okay,
Okay.
now I'm starting all the servers. Okay,
Mm-hmm.
so this is application contains multiple servers. Let's talk about this architecture as to what are these servers, how are they, and all that. Right now, let's just concentrate on the traffic. Okay, once this
Yes.
application starts, then we'll be
I
able
have a
to
like, very
monitor.
good idea about the AppDynamics. Like usually we call this as a nodes, and we used to add the servers so that how the nodes will travel from one node to the other node, and how the queries are passing, and
So
how to give the.
you have to get a feel for this. That's it.
Sorry.
So you know most of it. It works the same way, but just that the look and
Oh,
feel and the
yes.
things are different. That's it.
Even I installed the same in my system. This
Dynatrace.
Dynatrace.
Sorry.
Even I installed the Dynatrace in my system as well. I have been gone
Oh,
through.
so you're going through the things.
Yeah.
So let me install the system profile. Overview.
Okay. Something overview.
Okay, so my system is really slow. Okay, so here my today's agenda is to show you the GC, right? So let's go to the GC part.
Okay.
So hopefully, sometimes the setup works, sometimes it doesn't work because of my CPU running really high. I mean, my memory is running really high. You see, almost 100% memory. So that's
Mm.
why. So just the refresh. It will take a little bit of time, so we'll wait for that.
No, no, no problem.
So is it tomorrow there's an interview? So why you wanted it just today? I mean,
No, I
you
don't have
were you
any
saw.
interview tomorrow.
Okay.
The thing is,
So
they
you
told me like it is going to be either on Thursday. So I need to check. Tomorrow I'll be coming to know.
but with already the app dynamics knowledge you have, and you talk about this GC and all that, then definitely there will be investment. Okay, so what it is and all that. Okay, and I want to see that topology. Automatically, topology comes, but it is taking
Okay.
time. Now, why the topology? So I think it is taking little more time, Ajay. Okay, if you can wait, once the topology comes, I think my system is really slow. That is causing the problem.
No, no problem.
Transaction analysis running. Just a moment, please. Transaction analysis correctly running. So it's been doing that for a. Oh my God. Yeah, finally it showed up. My.
Yeah.
Okay, so go through at least one of them. Uh, let's go through this web server. Okay, there is process, there is transactions. Okay, so we'll go through the post. Okay, come on. See, summary, this utilization, show the health, and there is a process. So let's go with the first with the process. Okay, show web server
Okay.
health. Automatically a new tab will come and it will show you about the web server health. Okay, so here you have the threads as to how the threads are getting created. The ones which are busy are this color, the ones which are idle are this color, which means that the threads which are busy are less than the idle. Of the threads like this. And this is what we do from the LoadRunner as well. Okay, the CPU utilization. So we'll talk about this. We'll talk about the Dynatrace more. I mean, when we actually get into the Dynatrace part. Okay, but let me go into the place where you have the GC. Okay, where is my web server? Then, okay, is this a web server? Apache web server type. Okay, show the health of CPU, failure rate, and I think this is okay. So it should show the
Okay.
GC. This is the memory, network utilization, memory utilization, and the process. Okay, so then we have the process. This is what we looked at, right? Just give me a moment. So I'm just working on my signatures. Garbage collector should be in the problem. So you see GC is over here. Why is it not showing it? Okay, this is what it is. Okay, now watch here. This is what I'm looking for. Okay, now you clearly know what is an Eden space and a survivor space, right?
Yeah, I
Okay.
got it.
So see, now what is the committed in the whole heap time? This is what whole heap space. This is what is committed for them. Okay, this is, you see, it is a G 0 MB, and this is whatever the space is. So this has been committed. Don't get confused with this time. This time is for the city. Okay, GC time. Did you see that?
Okay.
This is the GC
Yeah,
time.
yeah.
The Eden space, the scale is over here. So this is the committed space. Out of this whole committed space, so this is what is being utilized. Okay, this is what is being utilized. As you see, these lines that you see, that is the GC. Okay, GC time means the garbage collector has come and taken away the space. Okay, so whenever you see, it is scheduled. It is scheduled accordingly, or whenever the GC will go over a threshold point, automatically the GC will come and take care of it. So the GC time will vary depending upon how much work it has done to clean up the GC. Okay, so as you can see, it will tell GC time. The GC time kind of how you can relate it to the CPU time. Okay, so you can say that more is the
Okay.
GC time. Somehow it is related. There are some calculations, and it is related to the CPU time as well. So it is requiring more CPU time. Okay, so that's how you can see.
Okay.
Okay, and you can see the time over here, it is saying how much is that, 30 milliseconds. Okay, at that point of time, whenever I have hovered, you look at it. So the
Yeah.
GC time over here is 30 milliseconds, and the used space is 16 MB. Oh, the overall committed space is 42.7 MB. Of all the RAM, okay, the RAM memory that I have is, let's say, 16 GB. Out of this 16 GB, certain GB will be allocated to the heap memory, and in that the certain MB will be collected to the allocated to the Eden space, and looks like 42.7 MB is allocated to the Eden space also. Okay,
Okay.
are we clear with this one? Can we move
Yeah,
further?
I'm clear. Yeah,
Okay,
sure.
so, and then the survivor space, as you can see, okay, so 5 MB, looks like 5 MB is allocated to it, and it is right over the mark all the time. Okay, it is even touching the maximum as well. Okay, so this is what it is. And now you see old generation, as I've told you, the young generation or the minor GCs happen very often, but the major GCs doesn't happen that often. It is less than the minor GCs. Can you see that?
Yeah, I can see that.
The major GC also, the allocated space is 100 MB, which is lot of, okay, as compared to the, okay,
It was
Eden
60.
space
Yeah.
close to 41, and the survivor is close to 5 MB. Okay, looks like I can clearly see that this one is a transition between the Eden space and the old gen. Think about it as a signal. Okay, between red and green, they will keep an yellow light as well, right? So it is a temporary
Yes.
light, okay, so that it cannot switch from green to red or red to green. Here also, instead of moving the objects directly to the old GC, they kept a temporary space, which is a survival space which is just 5 MB. Okay, again, this how much it will be changed from project to project, and how your developer has developed it. Usually the architect will take call on all that. Okay, so they will be looking into all this. Okay, now you see 100 MB, out of 100 MB there is certain, and you see whenever there is a GC, suddenly the memory decreases. You see there is a GC and the memory has decreased, but not enough. And there is a GC, the memory has fallen down, which means that so much of GC, so much of memory has been swept away or cleaned up. Okay, before the garbage collector, you see how much is the memory? Close to 60. After the garbage collector, the memory has decreased to maybe 50 of that. Okay, here also you see the GC time is there, the garbage collector has come, garbage collector has the program has picked up, the GC or the memory has decreased. This is the used memory, right? This is the allocated memory,
Yeah.
this is how much of the memory which is being used. So obviously the memory should decrease as well. Okay, on the first day when you have spoken to me, we have said, you said the memory should increase when the GC comes. No, the memory should decrease when the GC comes. Or you said, or maybe it could be some other person. Maybe it's some other person, it's not you. Okay, so but we certainly discussed about this at something we have discussed about the memory, but now you clean, now you're clear, right? If this is you're
I'm very
looking at
clear.
the looking at the used space graph, definitely if there is a GC, the memory should decrease because it is collecting all the unreferenced objects. Definitely, and it is freeing up the. Okay, now you see, and it is not happening, and I can clearly see that it is not happening at a regular period of time. There seems to be a trigger point of maybe 70 MB, and as soon as the memory reaches 70, that kind of GC will trigger. Okay, so I think
Okay, that means they might be created some health conditions over there. Whenever it is reaching to that point, so the major GCs would run, and it will need to clean up the mess.
exactly. That's what I'm guessing as well. And here also looks like that's what
Okay.
it is. As hidden space is getting filled up, it is running the GC is getting kicked off. Okay. And one more thing, good thing about this Dynatrace is if this GC time is way too high, then definitely the color of this moves to red, which means that there is an issue with your GC time. This is when you can report to the developer. You're getting the point?
Can you, can you repeat that
Yeah.
point, Kumar?
The good thing about the Dynatrace is here you look at this color, right? There is no problem with that.
Yeah,
But
yeah.
when this changes to
Hmm.
red, then definitely the GC time there is an issue. You can directly blindly go to developer saying that the GC time is more. The GC should not take this much time,
Okay.
right? You hover over it. Now you tell me how much is the mark sweep, and you see this is the concurrent mark sweep. Okay,
Mark sweep,
I'm
yes.
yeah, this is what we have discussed, right? CMS, concurrent mark sweep, and it's a major GC. And how much is the GC time? 127 milliseconds, right?
1
Can you
Yes.
see that when I
Yeah,
mouse
I can
over
see
it?
that, Kumar.
Yeah. So if this time is more, then automatically they color this differently. They color this into red color. Okay, it cannot be
Okay.
unlimited time. There is a time for that. Okay, as I've told
Hmm.
you, if this time is more, then the CPU utilization is more. You don't want too much of your CPU just doing this GC time. Okay, so the
Okay.
good thing about Dynatrace is if this is more, automatically the color of this changes. Okay, now the lines are in certain color, right? Now the color will go to red, which means that the GC time is more or it is not acceptable.
Okay.
You're there with me?
Yeah, I'm clear, Kumar. Very
Okay.
clear.
And I need to do more research on this suspension time, but I'm giving it as a hunch. Okay. My hunch
Okay.
is, and one more thing, you keep a count. You are wondering like how many threads will be created. You see, for this program, close to 30 threads are got created. Okay. These 30
Hmm.
threads could belong to only one process, it could belong to multiple processes as well. But you get a ballpark idea as to how many threads are created for this particular program. Okay, and don't
Hmm.
estimate this program. Actually, go back to I okay. I wish that I could open this in a new window.
What
Okay,
exactly? Thread dumping? How it will work, Kumar? Thread dumping?
1 minute. If you go back here, you see 277 requests are happening for every minute, which means that there is good amount of load which is getting generated. So don't underestimate this program. That's what I'm telling you. You got this?
Okay.
So it's a big
Hmm.
program, and then how many processes are running? 4 processes are
Food.
running. Okay, and I told you, right? Combination of threads and the program is a process. We have clearly discussed it, right? What is the process?
Yeah.
Combination of multiple threads along with the program
Combination of threads.
is a process. Okay.
Okay.
Now you see this 30 threads which are there belongs to how many process? 4 process. But we don't know which each process how many threads are there. But the ballpark idea you're getting that there are close to 30 threads, and these 30 threads belongs to how many process, and there are 4 processes running. Okay, so each one could be
Okay.
or it could be equally divided or differently divided. Okay, we don't care about that. Okay,
Okay.
and sorry, you were asking me one question, Ajay. Yeah, go ahead.
That is what the concept of thread dumps,
I'll
like
get to
how
that.
actually it.
Yeah, let's complete this and let's go there. Just complete the GC.
Yeah.
Yeah.
Yeah. Sure. Sure.
So yeah, and as I've told you, I didn't do the complete research on this. Okay, but
Mhm,
okay,
mhm.
as a first look, okay, I don't want to confirm until I've seen it with my own eyes. But the first look is, can you tell me now? Can you give it a guess? What is this GC cost suspension time? It looks straightforward. I didn't do research, but after me telling you that different GC algorithms, now you should be able to tell me what this one is.
That in what kind of intervals the GC has been triggered up?
Right. If you go back over here, my guess is if you clearly go back over here, okay, there is a certain
Mhm.
period over here which is the stop the world event is there, right? Because of this, there is
Okay.
nothing else is happening. Everything else is suspended, right? These application threads are not
Okay.
working. Only this GC is working. Okay,
Hmm.
so that's suspension. So I'm giving it a guess that this is the GC cost suspension time means the application is not doing anything at that point of time. Application threads are not working, which means that your server is not serving your application, and then all the threads or the whole CPU or the whole thing is working only for the GC. Okay, so I am giving it a guess
Okay.
that this stop the world event, right? This is what is the stop the
Hmm.
world event. This is the time for which it is suspended. Okay, and you see this is in the order of, let's see how much time it is. Okay, can you see how many milliseconds? 658 milliseconds.
58 milliseconds.
Okay, 1000 milliseconds will make a second, right? So 0.5 seconds
Yeah.
of a time. Half, close to half second is what CPU completely paused and it was not doing any of your application work, which I think is a little bit.
Mhm.
Okay, you can see here as 708, and it is going over here as well. It is close to almost 1 minute, more than 1 minute. Okay, so
More
this
than.
is, I don't know how much is back, but you should report this to your developer and talk to him. Okay, talk to him to see how much is bad, how much suspension is bad. But obviously, more is the suspension time, that time it is not serving anything else, which means that the request came to the server at that point of time. Definitely have to wait for 1 second because the application is not serving your threads. The server is serving the GC. Okay, so
Okay.
and I'm trying to relate it over here. Okay, as you can see over here, this happened around between 22:55 and 23. Okay, and close to 23. So during this 23, you see the GC time, it is more as well. Okay, so
Yeah.
major GC has happened around that time. Minor GC also happened. Okay, so both the GCs have happened. Okay, and probably and the GC time is also more, so that's the reason why the suspension time is also more, I'm guessing. And you see this patch of time between 255 and 233. Okay, and you see that memory continuously increasing and it is trying to go over the threshold.
Yeah.
So continuously the
Yes.
GC is scheduled, and as the GC is getting scheduled, this suspension time also is increasing.
Suspension.
Okay, and now my curiosity is, now we have to, in this period of time, how is the response times, right? If the response times is
Okay.
more, definitely this is causing your response times to be more in this interval. Not overall could be different,
Okay.
but I wanted to look at only this interval. Okay,
Hmm.
now you're understanding what is, what is bottleneck analysis, right, Ajay?
Yes, exactly. Yeah, I got it. How to go very into
Now
deep.
let's go look into the transactions response times
Yeah, sure.
for this time period.
Response.
I'll come to the
And
breakdowns.
even you can see the CPU also, it's increasing very high. The processor
Uh,
time at that particular point of time, it was reaching 100.
this one, right? Uh, where you're saying
CPU,
that
CPU usage.
CPU usage, right? So
And
here,
yeah,
the usage
post
it is 100.
process.
Yeah, I'm looking at this one. Okay, 2255 between 2255 and
Okay, okay.
23. It is not that much, but here it is high. Okay, So between 20 to 45 and 20 to 50. Okay. So there the GC is not. I mean, this CPU utilization has nothing to do with your GC time. Okay.
GC.
Definitely it has
Okay.
nothing to do. Okay. So it could be something else. Maybe you see the number of transactions has jumped. Okay. So you see the transaction flow. There was no transactions, and the number of transactions have jumped. Then suddenly the CPU utilization has increased.
Definitely.
Okay, which is expected. Okay, and during that time there is no problem. But as the transactions continue to increase, at some point of time the more work is happening, right? More objects are getting created. So it took a little bit of time for the objects to increase. Okay, so the number of transactions increased from 20 to 45. Okay, so after 10 minutes the GC, the garbage, I mean the garbage has increased. Okay, then the GC came into picture and continuously it is running to keep it under down. Okay, now between 20 to 55 and 20 to 30, yeah, the transactions are increasing, decreasing. But I am interested during this time period, what is the response times? Okay, so let's go look into the response times. Overall transaction response times. Okay, so
Directly,
I
there
need
is
to,
an option.
yeah, can you
Business.
please guide me where we can go find the response times?
Go to the previous page. No.
Okay.
I'm talking on the top of it. Yeah. There is a transaction flow. Yeah.
This is the flow.
Oh, it was showing.
Okay.
This is the flow.
Uh,
Okay.
this is the, I mean, the topology,
Business.
how the transactions are flowing, it is shown here. Okay. So,
Okay.
give me- okay, I didn't get a hang of this yet. Okay. I've used HP diagnostics. Okay.
You can go into the business transactions in the left corner, up to the dashlets.
This is like a by transaction level it will give you. Automatically it has
Okay.
created some transactions on those levels it will give you. But I wanted to give an overall
Oh.
picture of all the transactions. Okay.
Okay.
So
Okay.
that is on the transaction level. Okay. We can go to the pure paths. Okay. But here also I want okay, hang on. Um, I can go from here, but what happens from here is okay. Um, focus on past transactions. Okay. This is the hotspots. But I want over a period of time how the transactions were there. Okay. It will show over here, I'm sure. And you see here, the memory is the issue. Okay.
Yeah.
No wonder the GCs are having that problem. Continuously the GC is happening. Okay. And you see the page faults. During this period, there are a lot of page faults. Okay. Which is expected.
Okay.
Okay. This is when the transactions started increasing, right? 2240 and 2250.
Yes.
This is when the program starts executing. Initially, the program might not be there on your RAM, so it has to get it from your hard disk. When it gets from your hard disk, the page faults will happen. So there is an initial period of time the page faults will be there, and once most of the program has been loaded, then it is already there in the RAM, so it need not have to go to the hard disk and get it. So that's why the page faults are less. Okay, and now I can relate this to the CPU usage. So it has to go to the hard disk and get the pages from the hard disk and put it in your RAM, okay, or put it in your memory. There's a lot of CPU that is required for that, and definitely the CPU utilization for this period will be more, and that's exactly what you're seeing over here, right? You understand, right?
Yeah.
Okay, let's look at this,
Yeah. I
Ajay.
understood.
Let's look at this. Let's look at this way. Okay, so you're running a restaurant. Okay, so let's say like a burger. Okay, uh,
Mhm.
customers are coming in and something, all the material you already have it. Okay, like sauce, like you have cheese and you have dough, everything you have it. Okay, so already there in the store. Okay, there are two places. One is you have something at the back end where it's a warehouse wherein you store the stuff, and one is the kitchen where you keep the things ready. Everything is there in the kitchen. Then definitely as soon as the person comes, you make the pizza immediately and give it to him. Okay, then your efforts will be very, very less, and the time to serve your customer will be less. But let's assume some of the stuff is there in your warehouse. Okay, and the customer come in, you go to the warehouse, go get the stuff from him, then you make the thing. Then what happens? Your efforts is more, and the time taken to make the pizza is also more. So page faults is more like that. Okay, so what happens is, you know the concept of page faults, or am I just telling you, or you already know it?
Long back I have been read that. I need to recap
Oh,
that.
so quickly I'll tell you, since we are already there, but I'll go to the transactions, okay, and also the threads as well. Okay, so don't worry, I'll
Okay.
get to that. Okay, but since we are discussing, it's an interesting thing. Since it has happened, I wanted you to know. Okay, so now the most important thing, anything is, how can I draw this? How can I draw a box? Okay, okay, shapes, right? Okay, so oops. Okay, now think this is the CPU. Okay, this is the RAM. Sorry, this is the hard disk. This is the hard disk. Okay, and this is your RAM. A lot of interesting things are happening. You have to listen, or too much here?
This conference will now be recorded. Now be recorded. Now be recorded.
Ajay, Ajay.
Yeah, Kumar.
I mean, can we continue, or this is too much information?
No. You can continue. If you are okay, you can continue. For me, it's completely
I'm okay,
okay.
but at the same time, you need to understand, na? If you don't
Yeah, I'm
understand,
getting it. I'm getting it. I'm able to correlate with my
project.
business.
Okay, so
Yeah.
what happens usually, whenever, let's say you switched off the computer, Ajay, what happens?
Mhm.
All the RAM will be cleaned up, right? Now you
Yeah.
switch it on. Okay, now you open the Word document. Open the Word document. Okay, what happens? The program for the Word document. Okay, I'm talking about the Word document, but everything, it's the same story. Okay, the program is sitting on the hard disk. Okay,
Yeah.
is sitting on the hard disk. Now it has to, the CPU has to process that program. What it will do, what it will do, it has to get this program onto the RAM, because the CPU will execute the program only from the RAM, which we already discussed when we discussed about threads and process.
Process.
Yeah, so it has to
Yeah.
get this program from the hard disk to the RAM. It will not bring the whole chunk at once, because it has a lot of problems. So what it will do, it will divide the whole program into small pages. Okay, pages like,
Okay.
4 KB pages or 8 KB pages. Standard is 4 KB sizes, page size, but 8 KB. But these days, the size could be anything. The programmer will decide, even 4 MB, whatever the programmer wants, he will decide. Okay, so in small chunks he will decide, and these small chunks, they move from this. Let's say this is small chunk. Okay, so the small chunks, we call this as pages. They move the small chunks to this RAM. Okay, by the way, here the small chunks, we call them as pages. Here the same thing, we call them as frames. What do you call them? Frames. Okay, so once that piece of code has been moved from hard disk to the RAM, we no longer call this as a page. This becomes a frame. Okay, this becomes a frame. Okay, now let's say all these programs, all this program divided into multiple pages has been moved into RAM. Okay, now the whole program has been moved. The whole program has been moved. Now the CPU will process the program. Which means that it will be opening and doing anything. Now you see, the first time when I opened the Word document, it is little slow. Now the second time I'm opening, immediately it opens. You see, it opened
Yeah.
little fast, right? Because
Yes.
the program which is there on the hard disk is already been moved to RAM, and now it has to process from the RAM itself, because all the program which needs to run to open the Word document is already there in the RAM.
Okay.
You got the point?
Yeah, I got it.
Now the CPU, the very first time what it has to do, it has to do double work. It has to go get to the hard disk, put it in the RAM, and then from the RAM it has to process, which means that CPU is doing a lot of work. Okay, and it takes a lot of time as well. So during that time, the response times will be a little higher as well. And that's exactly what is happening. You see, this is the time wherein the page faults are happen, and that's the time wherein the CPU utilization is also more. Now you can relate both of this, right?
Yeah, I can relate it.
Okay, so that's the point. Okay, and network utilization is also high because it has to go get it from there. Okay, but where is our transaction response times? Okay, so let me go with one way that I know. Okay, so which is from this web server help. Okay, is this no here focus on passing transactions, show transaction details. Okay, so this is one place I can go get it. Okay, okay, but I wanted a graph here. Okay, so I wanted to see in that time period how was the response times. This is like the transaction flow, where it is taking how much time and all that. So this is the beauty about this one. But I wanted the graph of overall response times during that time period. Okay, so somehow I'm missing that information, or this tool doesn't have the capability which the LoadRunner shows. That I wanted something like that.
Obviously, there will be a transaction history. In AppDynamics, we used to do like that.
So it is giving the area wise, which is the experienced what. Okay, this is good as well. Okay, but response times is what we needed, na? Okay, but definitely when we get to the point, right? If we get to that point, definitely I'm telling you.
Okay. Usually in AppDynamics, how we used to do is like we will be writing a piece of code for that. They will be creating a function for that, so that we
Okay,
used to insert that particular function in the script, so that only it will be reflected in the tool.
okay.
That's how it is work. I don't know about these Dynatrace.
But definitely what I would want to see is when response times during this period. You see, the suspension time is more, definitely the response times over here will be high. This is my gut feeling. Somewhere, somewhere it is showing the response times. Okay, overall response times, not on the transaction level, but
Transaction.
overall response times it will be high. But one thing I get the feeling that you see, when this response suspension time is more, the number of transactions increased as well as an
Okay.
overall. Okay, during this time period, because most of the time the server is busy cleaning up the GC. So how it will serve the transactions, right? So
Mm.
transactions happens only when there are application threads, not when the GC threads are there. So I feel that it is decreased and the response time should be more as well. So if there is any way from where we can check if the what do you say, if the
The
response times during
transaction.
that time
Yeah.
period, definitely the response times, I'm guessing that it will be more. Response times will be more. Hmm. Uh, yes. Now we will go to the threads.
Yeah.
Yeah. So one last time I will try. There is somewhere it will give you the overall picture of transaction response times. On the time period, there is this one will give the pure path will give you, but the pure path will give you only uh, pure path will give you uh, per transaction, like not on the time basis or this basis. Okay, for this transaction, how much is the response times and the breakdown? That's what
Here,
it will give you. But I
here we
want
can
that.
in the top we can see like view is there, right? In the top right hand corner. So here path host details. Okay. I thought of you can change the view into graphical mode here in the
Yeah, yeah,
bottom.
yeah.
No, no. Here in the down also we have pure path host. It was, yeah. That's one maybe.
showing only the hotspots, which are hotspots as in something that you need to pay attention to, not everything.
Okay.
Okay. But I wanted to see it on the time period, the transaction response times on the time period. Okay. Uh,
Time for
Anyways, so
transaction.
next time around when we look into it, we'll look into it. Okay. But you got the idea as well, right? What
Yeah,
is
I
this
got it.
and all that? Okay. Now we'll go to the thread dump. Okay. So one thing you have to remember, okay, these threads will be in different stages. Okay. Thread is what? It will come and what is it? It will come and execute your program. Okay. So the threads are in different stages. So let's look at the life cycle of threads quickly. Okay. So that it becomes easy. Let me go to the internet and get you the life cycle of the thread. Okay.
Yeah.
So most of it is getting covered today, Ajay. Okay,
Yeah, it's
heat
getting
dump,
a lot
thread
of.
dump, and all that. So in the next classes, it will be only going through the Dynatrace and all that. Okay, so
Okay.
my WhatsApp, everything is not here. It got hanged up on me. You see, the application is running, and you see my soul. It's automatic. It almost killed my system. And page faults is also an important concept. Okay.
Okay.
So you see, CPU utilization was more. You are telling me certain period of time the CPU utilization is high. Why? It could be hundreds of reasons. Here you could clearly see that it was happening because of the page faults.
Yes.
Okay. What do I say? Life cycle.
Life cycle of thread and threads.
Threads. Okay. So as you can see here, okay, there are different stages the thread could be in. Okay, so the first, as soon as a new thread is created, okay, in the program they create this, right? Instantiation, new thread is equal to thread dot blah blah blah.
Thread dot
Okay,
travel.
so as soon as that piece of program runs, a new thread will be created. Okay, when a new thread creates, a piece of memory from CPU time should be given to it, and a piece of memory will be allocated to it. Okay, from the new, the thread goes to the runnable. Okay, from the runnable it goes to running. Usually runnable and running will be same. Okay, from here, okay, the thread goes to completely dead, which means that it's terminated, or the thread could go into the waiting stage. Okay, okay, and one more stage, the threads will be there, which is not shown over here. Okay, what is that stage? Block state, right? So there is one more stage which is in the block state, so which is not showing over here. So when the thread is new, there is no issue. When the thread is in the runnable, there is no issue. Okay, when thread runnable or running is same. Okay, thread is waiting as well, there is no issue, because it could be waiting for different reasons. But the thread in two stages is a problem. One is if the thread is in a deadlock, okay, then it's a problem, or the thread is blocked for a very long time, then it's an issue. Okay, when the thread will be blocked, okay, so thread 1 is using a resource. Okay, thread 1 is not what? It is using a resource A1. Okay,
Mm-hmm.
now there is this thread 1. Okay, 1 is there, and then there is thread 2 is there. Thread 1 is already using a resource. Let's say there is a resource over here. Resource could be anything, okay, an object or whatever it is. Okay, we already looked into the objects, right? So thread 1 is already engaging this object, which means that this object is an assigned object. Assigned, what did you say? Assigned, unassigned? What is the terminology we have used? Sorry.
Running.
Referenced object, sorry. Okay, so this object is being referenced to this thread 1. Okay, now this is using. Now thread 2 is also waiting for this object. So this will be blocked. This will be blocked for using of this until this is done. Are you getting this?
Okay. Yeah.
Okay. So thread 1 is blocked from accessing this because, sorry, thread 2 is blocked from accessing this object because thread 1 is already using that object. Okay, now thread 2, it obviously would have come from new, it went into runnable, and that is the reason why it knows that it needs to get this object. But now this has been already taken care by thread 1. This thread 2 will be going into the block stage. Will be going into the block stage, which is a bad stage. Okay, you don't want your threads to go into the block stage for really. Can you avoid it? No, there will be
No.
some threads with the block stage, but the problem is it should not be continuously in the block stage for long period of times. Okay, for example, now let's look into this. Okay, let's create a thread dump at this point of time. It's 11:24. We have created a thread dump. Okay, we have created a thread dump for whatever that server was. What server is? Customer front-end easy travel server. For this server, we have created a thread dump. Okay, now this is the thread dump for that. After 10 seconds, okay, I think we have 10 seconds have happened. Now you create one more thread dump on the same. Okay, now second thread dump is done. You see this one is done at 23:25 and this is done at 23:24. Okay, probably there could be 10 seconds time, definitely 46:5. There's 9 seconds time. Okay, now you take one more thread dump. Thread dump is what? A snapshot. Okay, you're going and you've taken a picture. What is that picture? It's your memory. It's a snapshot of that particular place at that point of time. You see, this is the memory snapshot at this point of time. At this point of time, how many threads were alive? 33 threads were alive. Out of that, how many were in runnable state? 20 are in runnable state. I told you, right? There is no runnable and running. All of them is safe. Runnable, all of them is safe. Good thing. What is that? There are no blocked. I mean, good thing. There's no deadlock is not supported because I've taken this as for free. Usually, it will be supporting and it will tell you if there are any deadlocks as well. So these are the two things that you look into, and you don't want any of your threads to be blocked or deadlocked. Time waiting will happen. Runnable will happen. Okay, and you wanted to see what are those threads, how many are there, and all that. You double click on this. Okay, you see these are all the 33 threads which you are showing, and each one which state it is also it is showing. This thread is runnable, this thread is runnable, this thread is waiting, this thread is runnable, and all that. Okay, like this, and you will also see when it is ready. Okay, this thread which is there. Okay, so it has executed these programs. Okay, it is executed this method. In this method, it is executing this line. It will tell you clearly what this particular thread has done over a period of time, and finally it should come to. It should have come to. This is in the runnable state, right? I will look into this. Okay, you see this is this has come into runnable and started running the program. Finally, it is waiting. It is running a method called wait, and that's why it is waiting. Okay, like this you can look into the history of it. This, and this was the thread dump for what? This is the thread dump for this point of time. Okay, now let's look at the thread dump for the next point of time, which is after 9 seconds. Okay, after 9 seconds as well, I wanted to look at the overall picture. After 9 seconds as well, it's the same story, so there is no problem with that. But if there were any block, okay, over here let's say there were 2 blocks for this thread dump. Then let's say there are 2 blocks. Okay, when you come back over here, you check if there are blocks, and if there are 2 blocks, go back to the thread dump and see if the same threads are blocked. Okay, if the same threads are blocked, then you go back to the next thread dump. Okay, and the same 2 threads are blocked, which means that the threads are blocked for over a period of time. Okay, which is long. You don't want the same threads to be blocked for a longer period of times. Okay, if the same threads are being blocked for a longer period of times, then definitely you should report those threads. Let's say this thread called http bio. Okay, http bio 8080 execute 1 is continuously blocked for a particular period of time. How do you know it is continuously blocked for a particular period of time? You take the thread dump for every 10 seconds and you look into each thread dump, and the same thread has been blocked continuously for a period of time. Then you say that this thread is blocked for 20 seconds. You see, 10 seconds and 10 seconds, 20 seconds, then definitely report that thread to the developer saying that this is being blocked for a longer period of time. And if the thread is, and if the particular thread is deadlocked, you need not have to look into the other thread dumps. If it is deadlocked, it will stay deadlocked for the whole period of time, and that needs immediate attention, because deadlocks will eventually might lead to memory leaks as well. Okay, so definitely you need not, once there is a deadlock, then you double click on it and you see which thread is continuously getting into the deadlock, sorry, not continuously, but getting into the deadlock, and immediately report to the developer saying that this particular thread, is in the deadlock. You need not even have to look at the other snapshots. When you look at the other snapshots, if there is any blocked threads and the same thread is blocked continuously for the other snapshots, and you don't want it to be blocked for too much period of time. Okay, imagine, Ajay,
Okay. Yeah.
if the thread is blocked, what the thread will do, it is serving your request. Okay,
Yes.
and if the thread is blocked for 10 seconds, which means that your request is not served for 10 seconds, which is a huge time. You see the difference between these thread blocks is 10 seconds, right? And the
Yeah.
same thread is blocked for 10 seconds, which means that your response times will definitely be greater than 10 seconds, because that thread is representing your request eventually.
But yeah, when deadlock is happened, that the complete transaction will get failed, right?
Lock has happened, it will stay deadlocked forever, and from your point of view, the transaction will fail because there is a standard time of 120 seconds or something like that, right? It cannot
Yes.
wait more than, your request cannot wait more than 120 seconds or something like that. It will
Yes.
wait, and it will, the server is not getting the response. Your request will be killed, and as an end user, you will get 404 page not found or some error from the front end. Okay,
Yeah.
but behind the scenes, it will still stay deadlocked and it is occupying your resources, which is bad.
Okay. Yeah.
Now, are you more confident, more,
More, more,
exciting?
more confident, more than before.
And isn't it exciting looking at all this? Oh, there's a page faults over here. This GC time is more, then suspension time is more. I wanted to see what is happening to transactions per second. I am telling you, if this is the kind of information for this window, if you're calculating all this and telling in your observation, uh, more than
Because
enough.
like,
He will be
yeah.
jumping in.
Yes.
Okay, and there is one more thing, since however we are talking about, I'll tell you this and I will wrap this up. Okay, so there's one thing that you wanted to look at in the transactions is, okay, so this is the flow, right? So let me look at the hotspots. Yeah, response times, not I am clicking on that all the time. Okay, we're looking at the pure paths, right? You see this is a request, orange.js. Okay, so you see so many requests. So I mean, behind the scenes, this
Behind.
particular request is kicking off this request, and inside that it is kicking off another method like this. So much is happening inside the scene. Okay,
Within a
but
class, there are multiple methods and
multiple
functions.
classes, methods, and functions and all that. Okay, but what you want to look at is out of this 8.75 milliseconds is nothing. Okay, but you see how much is the CPU and how much is input output. Input output could be different things. Okay, CPU utilization, sorry, network utilization and page faults and all that. Okay, so you see the CPU utilization, you don't want it to be too much. Okay, and this one also, if this is too much, you need to pay attention as to why this is too much. Okay, and one more thing is this orange.jcf could have been executed multiple times. So you watch that carefully as to how many times the orange.jcf has been executed. Okay, and see continuously. If the response times are increasing, then there is a problem. Okay, so most of them is around the time. You see this one is more. Okay, this one is more orange.jcf. Okay, so ideally you want it to be at the same levels, but sometimes it is more. Then you have to pay attention as to why it is more. Okay, so you see sometimes it is even more, and this is definitely you need to look. Okay, and out of this, most of the time is 97% of that is input output, which means that something it is downloading, right? We discussed about that web page diagnostics, right? Remember
Yeah,
that?
we discussed that. I remember that.
Input output means definitely it is downloading something. Okay, maybe you can look at it as to what it is downloading and all that. And here, out of that 97%, 262 seconds, see which one is taking more time. Okay, so overall here 62, and here it is still 262, but here it came to 13. So somewhere over here, a request is taking a lot of time. Okay, somewhere over here it is taking a lot of time. Oh, here you see input output is completely 100%. So this one is taking a lot of time, and most of the time seems to be the input output. Okay, which means that it might be downloading some big files or images or something like that. Okay,
Okay.
let me see. See file cluster orange.json. Okay, so definitely this is something that this is abnormal. Okay, you need to give this information to the developer saying that no, this is not right, you know, it looks abnormal. Okay, maybe it's downloading a file which is of big size. Okay, and somewhere it should say something like, you know, how much file it has downloaded and all that, how much is the downloaded file. There's something that it should tell. Okay, so
There is an drill down option is near the web request. There is an just like something arrow mark.
size, can it show you some size typically drill down? Agent break, visits, web request, business transactions, method hotspots. Um, but I wanted to see how much of the data has been downloaded from the server to the client for this web request. Okay, so somewhere if you can get that picture, then you know how much is being downloaded. Okay, but I'm sure it is downloading something. Okay, let me quickly see orange.json. Okay, so what is this IP address? This is the one, right? We are looking into this, right? Okay, so it is 8080, right? Localhost.8080, localhost hyphen 8080 and JSL. Okay, so let me search that. Okay, this is on the localhost itself. Localhost, okay, 8080, right? Okay, it will show you the server. Okay, wonderful. The application has opened. Now, in that, what we are looking up, can you remember the resource? Orange.jsf, right?
Orange, yeah.
.jsf.
Yes, F.
You see, this is the image. Looks like there is a big image. Let me look at this.
There are multiple images.
Is this orange.jsf only, right?
Yeah, orange or DSF.
So let me go to the pure for a second. Yeah. Okay. So orange.jsf with a forward slash. Yeah, with forward slash orange.jsf. I'm sure it is downloading these pictures, and this picture it is taking a lot of time. Okay. So maybe you can look at the size of this. Okay. Save this onto your desktop. Okay. Let me save that on your desktop. It's header 4. Did I save it? No.
The documents it may be said.
It's there in the documents. Okay, so let me go to my documents. Okay. Header, right? Okay, so let me go, let me go to the image size image. Okay, it is just 63 KB. That should not be a problem. 63 KB is
Yeah.
nothing. Okay,
It
so
was
let's.
completely dynamic images are coming up over there every time. Lot of images were happening in the background, I think.
So again, you go to this. My road will look into it. 250. This shouldn't be a problem as well. Only if it goes into TVs, then it's a problem. But maybe
MQ,
that time, as you said, there are dynamic pages, and around that time I think it was trying to download
Trying to
the
download.
times was more maybe, right?
Yeah,
Because there are other times wherein it is in milliseconds itself. So as you said, it could be dynamic pages,
yeah.
right? You see this image.header.png.
One
Okay,
image.
let me see that img/header.png. Okay, slash
Slash header.
header.png, right? It's just this image,
Header
but
one.
just
Just do header one.
this is header one.
Head-
Header one. Sorry,
Header one dot png.
this
Yeah,
image.
yeah. This
Okay,
image also
now
was running dynamically.
dynamically, and you see, just to download this image, it has taken so much
It's
time.
taking.
And
Yeah.
definitely, your developer has not zipped it before
Zip.
sending the file from server to the client.
Yeah.
This is, I can right away tell you, because you see, for this resource, nothing else is there. It's just the image,
Image.
right?
Yeah. Yeah.
Download this image, it's taking this much time. Certainly, 100% I can tell you that he's not zipped it before putting it on the network and sending it to the client. You're getting the point, no? I mean,
Yeah.
how
I'm getting points. I'm very
overall
sure.
idea as to what it is. Okay, definitely if
Yeah.
there are images, that's what you look into, and you want overall the CPU and IO should be equal, but overall if the response times is more, and you then check what it is. If the response times is
Okay.
really high, as you can see here, the 1000 hardly there is any CPU utilization. Everything is input output, which means that the download time is more, right?
More.
Which means
Yeah.
that the size of the image is really high.
Hi.
Okay, all this, if the CPU was high, definitely then CPU means there is threads, there is some program running, and definitely you have to look into the methods as to why it is running more, which method is taking more. But here you need not have to worry which method it is taking more, because the CPU itself is less. The most of the
Yeah.
time is about input output only, which means that
Yeah.
CPU has served it, but for downloading it is taking a lot of time, which means that definitely they haven't zipped it before sending it out. Okay,
And then,
usually zipped
yeah.
files in the order of KBs. Here it going
Yeah.
into, I mean, I don't even know how much it is, but it would have went into MBs.
Yeah.
Okay,
And at the same time, if you see in the tool, he did it in a synchronous process. It should not happen in synchronous process. It should be always in asynchronous process.
so yeah, we'll look into this. And somewhere over here, does it show the size as well,
No,
Ajay? In each, no,
no, no.
those will not show you the size, right? Okay. And what you're telling me, Ajay, one more thing, synchronous
If you
thing.
go into the Dynatrace, just keep the cursor on that header
This one, huh?
one MG. Here, if you see, can you drag this to end the pure path details?
Okay. So once I remove, it's going away. So I don't know.
Yeah.
Maybe details. Yeah.
Yeah, details. If you see, it was did on synchronous process, CPU sum, 5 synchronous sum he has given. The complete, it should be in a synchronous process. Top findings, if you can see here in the, yeah, they have given top findings. Asynchronous, no asynchronous. But if you
Okay.
see in the CPU sum, they have written it in synchronous sum. It should be always, should be in asynchronous sum.
Okay. So it should is it synchronous asynchronous sum, and this no asynchronous, which means that it's synchronous. That's what you're telling, right?
No, this is synchronous sum. The image that which he has been did in synchronous way, but it should not
Okay.
be. It
Okay.
always need to be in asynchronous process only.
Asynchronous process. Okay. Asynchronous means it will not wait for anything, right?
It will
So
not
it
wait
will.
for anything.
So there is no dependency basically. This should not
Yes,
have any asynchronous. So it says asynchronous is no asynchronous, which means that it is synchronous, right?
yes, exactly.
So that could be a problem as well. Okay. And suspension time because of that is 83 milliseconds. I don't know that.
Wow, this was a good tool.
Execution time is okay. Size. It is saying size. What is that size for? I'm
Size.
curious about. Okay. Response times. It's a lot of time out of this. most of the time duration execution is this much. Okay, size is that much. Okay, agent ID, fine. It says response times very slow. Okay, which is true. Complexity normal, size large. I think this is the problem. You see, size is large.
I think acceptable. That means he has not created any thread for that.
I think it is created. Acceptable means it can be accepted, and they would have created. So
Maybe.
that will not be downloaded, and this I don't think so. But size is large, and as you
Yeah.
said, it's not synchronous, and then response times is very slow. Okay, so that's the top findings.
Yes. That's so good. That's nice.
Okay, fine. The here also, if you can tell, like you identify the response times which is high. Here again, input output is there, so you have to figure out, why this input output is more. 94% of this is out of this, so we have to figure out why it is taking that, and we have to talk to the developer, and maybe if there are emojis there, you have to talk to them. And if CPU is high, then we have to see which method is taking more time. Okay,
Yes.
which method is
Okay.
taking more time. Okay,
Yeah.
so this is about it. Any questions?
No. God, everything is clear up to now. I need to recap all these things tomorrow, and if I'm having any doubts, I'll let you know by the next class whenever you're going to take up.
Okay, this is getting recorded, so I'll send you the recording maybe tomorrow, not today. Okay,
Yeah, sure. Yeah,
so
sure.
you're in a better shape, Ajay, in general, overall picture from this last 3 or 4 classes.
It was really, really helpful, Kumar, for me.
Okay, okay.
uh,
That's what I wanted to hear from you. Okay, so the next class probably like tomorrow I'm fasting, so I'll not be having the energy to tell anything. Okay,
sure.
so day after tomorrow I'll come back and then we'll start the Dynatrace itself. Okay, whatever
Yeah.
we could. So every week we'll take 1 to 2 classes, Ajay, because there are a lot
Okay.
of other works going on as I've told you. Okay,
Oh,
so expect only 1 to 2 classes per week, not much. Okay,
yeah. At least
so
3 weekend. Is that possible? Why? Because means already I uploaded my CV into job portals.
okay.
I'm
But
getting calls.
this information should be good enough to get
Yeah.
started, Ajay.
Yeah.
For
This
example,
information is good enough.
page
Till to.
faults, okay, all this is a lot of information. Now, most about is Dynatrace, how to use it and all that. Okay, what is this
Okay.
application, architecture of this application,
Mm-hmm.
system profiles, mostly getting into it, not on the performance engineering side.
Okay.
Okay, so I'll try to, as you've suggested,
Yeah,
but
you
the thing,
you try it. If not possible, like this, if you take continuously for 2 hours, 2.5 hours, that will be sufficient for 2 classes.
okay, yeah. Okay, Jay. So I'm really hungry. So let me have some
Yeah,
dinner.
me too.
Okay. So I'll see you next class whenever it is. Okay.
Yeah, sure. Thank you, Kumar. Thanks for your time.
Yeah, yeah. Anytime, anytime. So enjoyed the class. This is very rarely I get into this area because
Oh,
not many people can understand this actually. They will be
uh,
totally. I mean, you're able to quickly relate, but
yeah. Why?
people
Because
will.
means I'm into this, right? So I'm able to correlate with whatever I'm doing and the stuff, how analyze and how you are explaining. I was
Fast.
a little bit fast.
Oh, recording, right? You
Kumar,
wanted.
if any interview is scheduled, means I'll come to Hyderabad, Kumar. Is that
Yeah.
fine, right?
Right, right.